Welcome to the first session of the selective signals and systems. Because of the pandemic situation, we are still unable to meet face to face. Therefore, at least for the first half of this course, it seems that we have to meet online. This course, Signals and Systems, is very fundamental course in any branch of engineering. It is a very general purpose course wherein the contents are not branch specific but quite general in nature. Generally, this is not very simple or that way quite easy or non-significant. General in the sense that any individual who works on actual physical system can understand all these principles. We will be taking various examples so as to give you feel of the subject first, and then all the contents which are there that I will introduce slowly. Since the discussion requires some kind of interactive things while talking, I have to explain on the board. Then instead of using some kind of online session and slides on Zoom, what I think is that I will record the lectures and then we will be having regular interaction sessions so as to address the doubts in the contents which have been hopefully watched by you. Not hopefully, I think it is certainly. So, being the introductory lecture, I will be quite simple, and few of you may feel that really am I in an engineering college, can the discussion be so simple? But slowly as we proceed further, the complexity of the contents has to increase because it is the requirement of the subject. It is not that it is not to make purposefully difficult, but it will not be too simple as you find today. So today's session, being an introductory session, would be just to make you aware about the subject itself. So, signals and systems. So from that point of view, instead of defining directly the system or signal in some classical terms, I think we will take an example, and after taking an example you will understand what exactly we mean by signal, what exactly we mean by system, and so on. So, to be very precise, if you have Google at your fingertips, not at even your fingertips, you can use Google Voice so as to avoid the efforts in typing. So everything, every information, whatever is there in the syllabus, each bit of the syllabus you can take, you can Google it and you can acquaint yourself about the content. But so in this scenario, the question remains, what is the relevance of a classroom teacher? What is, why at all teaching is separately required? And I will try my level best to ensure that the gaps which remain between the material readily available to the students otherwise and the expected understanding from them, whatever is the gap, the teacher is expected to address that gap. And first of all, now see what I listen very carefully, it's a very interesting thing. Now, earlier getting information was a problem. Now sorting information has become a problem. Students of CS and IT would be aware of it. So, suppose if this subject is there and the first bit in the syllabus, signal. So the moment at which you get the word signal, you can Google it and find the contents, you can read it, and you would be very much comfortable with yourself of the understanding of the contents. Now the question is, what is the role of a teacher to address the gap? It may happen so that the students, because of huge availability of information and reading it, may not be able to understand whether their reading and understanding is complete or not. So unless a skillful teacher makes them aware about the gap is not even understood by them. So a teacher is to address, teacher is to make aware, means he can, I will also, it's not that, means in earlier days there was some kind of practices followed by few teachers. Not, anyway, it's not that it used to happen here, but it's some phenomenon which is known by many. The teacher did not used to tell the name of the book to the students, so that he was afraid that if they read the book, what is my role? So he used to, without telling name of the book, and availability was not also so easy, so teacher used to tell this small bit of information in his lectures so as to make himself exclusive, to maintain his monopoly. Now that is not possible. Therefore, I will be giving you the I will be giving you the list of the websites, list of the video lectures of other teachers where the contents are readily available, and then I will expect you to go through them. I will expect you to go through them, and then I will point out the gaps and address them. Okay. So let us now begin with the very definition of a signal. Very definition of a signal. What is a signal? If you go through the book definition, classical definition, not necessarily the book, maybe now web definition we can say, because book you don't follow. It is mapping of one variable with other variable. It is mapping of one variable with other variable. And a signal can be hypothetical. I feel good. So feeling good is hypothetical signal, but let us not, what we can say, spend time on them. Let us restrict ourselves to a meaningful definition. It's not that feeling good is not meaningful, but let us be very much practical at the initial stage. So, when I say mapping of one variable with other variable is a very general definition. Instead, what I would like to means mapping of one variable with other variable is a classical definition, but let us not at initial stage try to be too classical. Let us be very practical. So to be very practical, and remember that whatever we discuss in the classroom is not necessarily everything is scientifically correct. In order to ensure that the classroom discussion, the prime objective is understanding of the students. Therefore, in order to help understanding of the students, it is expected that a small deviation from scientifically correct things should be rather followed so that students understand well. So the discussion which we carry out may be somewhat, not diametrically opposite, but somewhat away from the scientifically correct things. So I am sure that you understand that. So what is a signal, to be very precise and practical, is mapping of one variable which is some physical, which is some physical phenomenon with time. I am narrowing down the definition of a signal to make it very practical. So signal is mapping of one physical parameter. We said one variable, other variable. Then I said one variable which is reflection of some physical phenomenon, or to be very precise, mapping the signal is mapping of one physical parameter with time. So what are the physical parameters? Physical parameters are mass, or to be conveniently and alternatively used as weight. Right now we are not focusing on gravity. So mass, then length, then temperature, pressure, speed. It is again a position versus time. So speed versus time, I hope you understand, even though speed includes time as in its denominator. So to be very precise, it is a derivative of position versus time. So anyway, that speed but you understand it. So what is a signal? Signal is mapping of one physical parameter with time. So temperature, pressure, mass, or level, water level. Suppose, and we will take this example of water, but that is very important for everybody. So it's a tank, and in that, so it's a zero reference level with respect to which we are measuring, and the water can come inside the tank, water can go away from the tank. So in that case, water level will change. So some physical parameter with time is signal. What is system? What is system? What is system? A system consists, and to add to this physical parameters, we consider electric parameters, which you might be aware of: voltage and current. These are also considered to be very much meaningful parameters, even though you can't sense them with your hand. These are also very much useful parameters because most of the things is electrified in the world. So just we cannot now you cannot imagine a system without mobiles. Like that, without electricity, means there used to exist a world which did not use electricity for day-to-day life. So it was there, but now we can't think of that. So electric signals are also very much there. Now, what is a system? What is a system? So, to be very precise and simple, I will explain. A system is some physical arrangement to which one signal acts as input and the system results in another signal which is an output. System is some arrangement of some physical entities, say tank, valve, etc. Tank, valve and so on, in which one signal acts as input to it and the system results into or delivers another signal which is an output. So one input signal and one output signal are essential for something to be defined in the system. The input and output signals can be of same type or different types. Can be of same type or different types. Now I will take one example of what is a system. I will take one example of what is a system, explain to you in detail, and you will understand how do we work on the system. So I will be going for a very detailed discussion of the water level system, because that is something which everybody can understand. But prior to that, I will explain one simple system of a voltmeter. I think now with everything being electronic or digital voltmeter, but still in your junior college days, we are fortunate, I say fortunate only, that this syllabus is getting revised slowly, so that you must have, I am very much sure that since in your 12th you were very much particular in studying everything, you must have studied of a moving coil galvanometer. You must have studied of a moving coil galvanometer, and when you connect a large resistance in series with this moving coil galvanometer, you get a voltmeter. So what is a voltmeter? A voltmeter is a moving coil galvanometer connected with a very high resistance in series. So, and let it be a center zero galvanometer. So what you have got is this one. And this is the scale. Let this angle be 45 degrees, not necessarily, and let this be minus 4.5 volts and plus 4.5 volts. So you are adjusted by putting a very proper resistance in series. You adjusted that for voltage input V in, that for plus 4.5 volts the current would be plus IFSD, and that will mark as plus 4.5 volts. You adjusted this RS suitably. So to be very precise, see there is nothing new here. When I connect plus 4.5 volts, when I connect plus 4.5 volts, I get the position of, this is a magnetic needle, we can say appropriately, not magnetic needle, this is some arrangement where we are using electromagnetic effect, and the pointer of the moving coil galvanometer is at rest position, when there is no current, and when we apply voltage to it, there is a series resistance, so some current flows, and the pointer of the moving coil galvanometer moves appropriately in a proportionate manner with reference to input voltage. So this is a system. What is system? This galvanometer itself with this resistance, this become part of the system. This is system. So for this system, what is system? Voltmeter is a system which includes the permanent magnet, moving coil, a proper spring and a resistance in series. For this, so this I say a system and I represent it with a black box. To this system there is an input and the system delivers an output. I will try to explain. This is very simple, but a deeper meaning is attached here, that also I will address very appropriately to you. So for this system, as I said, that system needs an input signal and system has to give an output signal. So one input signal, again that signal is a physical parameter with time, and an output signal which is also a physical parameter with time. The parameter can be same in the same units or the different units. So in this case, so therefore, what is the input to the system? V in. And unless otherwise specified, the signals are mapped, or signals are mapping of a physical parameter with time. Therefore, we express always, or for this subject, except means I will explain some non-real time, some other signals, just to tell you that signal need not be always with time signal, but otherwise it is time signal. So it is V in T is the input signal. So for this is a voltmeter. The system is a voltmeter. So for the voltmeter, the input signal is V in, so I will use in and bracket T. And what is the output signal? What is the output signal for voltmeter? Then one will say voltage which it gives. The reading of the voltmeter is voltage. No, that would be again a wrong way of explaining, even though it is what he is saying is not something which is completely false, but it is wrong way to represent. So what is the output of the voltmeter? I am talking about output of a moving coil voltmeter is angle of deflection. That is the angle which the pointer makes with its rest position. So that I define as theta O into bracket T. Theta O into bracket T. Now just by taking this example, as we move ahead, you will find many complex things that you will find. Let us see how. So, what is the unit of input? Is in volts. What is the unit of output? What is the input signal? Voltage. Voltage signal, its unit is volts. What is the output signal? Output signal is angle of deflection. Angle of deflection. So what is the unit of angle? Can anybody explain? What is the unit of angle? Then again, if you are too classical, you are students of a Walchand college, a very reputed college. So you have to be classical. So to be very precise, whether the angle is having any unit? No. Why? Because angle is ratio of arc upon radius. Angle is ratio of arc upon radius. So ratio of distance upon distance. So being a ratio of same quantity, it is unitless. So angle is unitless. But right now see, this is also very important point to note it down, that angle is unitless. So angle is unitless is very classical information and very correct information, scientifically correct. But in most cases, if we unnecessarily stress on scientific correctness, we waste our time and energy and we lose the crux of the content. So it is not required that angle should be in radians. Then radian, I see the way in which an individual is born and brought up makes a very significant impact on his further working style. So radian was something which was introduced to you at a very late stage. Till that time we are used to degrees. So 45 degrees is something which we immediately understand and not 1 radian. So radian again we have to realize by using 1 radian corresponds to 57 degrees, and that gives me the understanding of radian. It's not that the 1 radian means that arc which is same as the radius. So the unfortunate story of Indian English medium schools is that the teaching learning, the medium of instruction for teaching learning is English, but medium of understanding for an individual is happening to be his native Marathi. So when a teacher talks in English, at my own internal level I convert it into Marathi and then understand. So when I say, if you decide that we will talk in terms of radians, then radian, to understand how much angle it is, you internally convert it into degrees and then understand. So there is no point in unnecessarily focusing on radian because it is scientifically correct. So let us say that, okay, let us be very much practical, not scientifically correct. The output is an angle and its unit is degrees. So what is a system called as voltmeter? I think now I will have this out, or I will draw it separately because I have drawn it at a wrong position. It occupies the prime position of the screen. So what is a voltmeter? Voltmeter for the system theta OT is an output signal and V in T is an input signal. So what is a system? In a system, it is obvious that the output signal must depend on input signal. In a system, output signal must depend on input signal. The manner in which it depends and all that mapping we will do, but dependency is must. Otherwise, it will become a random system. Means, if the question paper is an input signal and the answer sheet is an output signal, then there has to be some kind of some kind of relationship. In MCQ that can't be seen, but in conventional papers, what we can have is that if a question is asked, the answer which student writes must have some relationship. Otherwise, if there is a very casual student who writes you might have heard that, oh, I wrote the picture story and still I got marks, just to ridicule the system. So that would be a random system in which there is no meaningful relationship between input and output. Whereas in a meaningful relationship, we must be able to define that mathematically. The relationship must be defined mathematically. So I said that I have adjusted the resistance of the voltmeter such that for 4.5 volts it should give me 45 degrees. So what is the voltmeter equation you can write? So every system must have some system equation. Every system must have some system equation, and on the left hand side of the system equation, what we must have? The output signal. On the left hand side of the system equation, you must have an output signal. So the system equation must be theta O T must be equal to, and on the right hand side of the system, equation, input signal must be there. So V in T must be there in some other form, maybe direct form, maybe some square if the non-linear. Right now it's a linear system. So theta O T is equal to, how I have adjusted? I have adjusted it such that for 4.5 volts it results into 45 degrees. So what is the constant of proportionality? Constant of proportionality here is 10. Do you agree? So theta OT is equal to 10 into V in T, and only thing is that you should be very much clear about the units. So because unless you don't tell the units, it will be insufficient information. So theta OT is equal to 10 V in T, where input voltage signal is in units of volts and output deflection angle signal is in terms of degrees. So theta OT is equal to 10 into V in T. This is the system equation. So for a voltmeter system where input is a voltage signal and output is a, to be very precise now, rather than deflection, I will use a somewhat not too scientific but better. That is, input is voltage and output is position, but it is not a linear position. So as to make it very clear, I say output is an angular position. So input is a voltage, output is an angular position. This means a voltmeter system to which input signal is voltage signal, output signal is angular position signal, and theta OT is equal to 10 into V in T is the system equation. This is signals and systems. Now I would like to ask, whatever I have described, theta OT is equal to 10 V in T, does it describe the system equation correctly? If the answer is yes, in that case, the course signals and systems would not have existed as a full-fledged one semester open elective course. The discussion was not required. So now I am asking the question, since it is online, not face to face. There is no need for me to wait. Those who want to think can wait, can put the video on pause, think on their own, think of the answer, put on the video, verify the answer. Those who can't get the answer can again put on the video, watch the answer. Those who think that I can't think of the answer need not pause the video, hoping that all are watching the video, and continue to watch the video. So my question is whether the equation which I have written, theta OT is equal to 10 V in T represents the correct equation or not, and if not, what is the problem? To be very precise now, then you will say no, it can't be exactly 10. There may be some kind of mismatch in resistance value, measuring of angle, so that we ignore. So correct what I say, that accuracy, I am not saying, my question not it's an accurate equation or not. My question is not that whether it's an accurate equation. Accuracy is not so important here. So there may be some calculation, what we can say, measurement mistake, parameter value deviation that is permitted. So my question is, means your answer need not be focused to the exact value of 10. So that is not an important issue. My question is a fundamental question. Whether theta OT is equal to 10 V in T is a correct equation of the system, or there is some fundamental change. As regards to, I am not talking of accuracy. So the answer need not be focused around the exactness of the multiplier 10. It is a very fundamental question. So you can pause the video, think on it, and then you can resume the video. This question is the crux of this entire subject, signals and systems. The question is, the described voltmeter system equation is put there. Is that correct? Or you can think of scenarios where this equation does not get satisfied, does not remain true, and so. So you can pause, think, and resume. Okay. Listen now very carefully. We said that the signals are time signals. So input is voltage between 2 points, output is angular position, which the pointer shows from rest position or zero position. Now, when I say that it is a time signal, suppose if you give 3 volts DC supply, 2 battery cells, you will measure 30 degrees, and that would be there. If you remove one cell, give 1.5 volts, it will show you 15 degrees. If you take 3 cells, you will see 45 degrees. So all this discussion is for constant signal. Instead, now listen very carefully, here is the crux. Suppose if you have a potentiometer, you have, I'm moving very slow. Potentiometer or variable resistance concept you know, or why that even that variable resistance. You must have seen since the first year you had gone through offline education, in some or other experiment you have used, or even in 12th also you used a DC power supply, and there is a knob, and these are the two plus minus, and this is the knob. So this is a power supply. So you can vary this knob as you wish. So if you now connect this a variable voltage power supply to your voltmeter, and you start varying the input voltage, means if you change V in T rapidly, if you change V in T rapidly, I think now it's a very, why this subject signals and system is said to be a general subject is because of the fact that it deals with the scenarios which are quite natural, which everybody can understand without much domain expertise. So it is very obvious that what will happen, that its maximum point is 4.5 volts, let us say, and minimum is 0 volts. So the power supply which you have got is 0 to plus 4.5, that is its maximum 4.5. Again I have chosen it deliberately so as to simplify the things, and minimum is 0 volts, and you decide that yes, I will play with this now. Very rapidly you change the position of the power supply. Then what will happen? Then obviously this is something which you being smart, there is no need. What will happen is that when you change slowly, when there are 0 volts it was 0, when you go on changing slowly to plus 4.5, it will come to plus 4.5. Again if you take back, it will go to 0. So as long as you are slow and varying from 0 to 4.5 and 4.5 to 0, it is following it appropriately. But when you increase the speed of movement, what will happen? That ultimately, listen now very carefully, I am trying my level best to simplify. In the voltmeter, the output is an angle. Output is an angle. And every physical system in the world is having inertia. And human being is the most classical example. And an engineering student is then an ideal example of a system with inertia. So because of this inertia, what is inertia? Reluctance to change. So because of this inertia, there is a limit with which, listen very carefully, I am trying my level best to explain the things in most simple manner which need not be scientifically correct. What is the output signal of voltmeter? It is angular position. Output signal of voltmeter is angular position. So, because of the physical element of that spring, the weight of the pointer, or that actual pointer, it's negligible, but it is there. So, because of overall physical arrangements, what is going to happen is that there will be a maximum rate at which the system can respond. Listen very carefully. There will be the overall limitations because of inertia of physical arrangement will lead into a figure that is the maximum rate at which the system can respond. So that I will define as, in operational amplifiers it is defined as slew rate. It is very similar to that. So just it's not required by you later on, but just understanding, the permanent magnet moving coil galvanometer is converted into voltmeter. Such voltmeter, because of its physical arrangement, has got a limitation of the maximum rate at which the pointer can move. It is slew rate and its unit is in degrees per, you can say, per second is very large time, so it would be very huge figure. I can say microsecond. Means there may be good quality voltmeters, poor voltmeters. A good quality voltmeter will have this rate as high, so it can deflect at 10 degrees per microsecond, whereas some can deflect only at 1 degree per microsecond. So the slew rate is the maximum rate at, listen very carefully, the maximum rate at which the pointer of voltmeter can change its position. So its rate of change of angular position with respect to time, which the voltmeter can't exceed. Right? Okay. So now the question is quite obvious. If the input is input voltage signal and you are changing by hand, or it may come from some other signal, or you can connect AC also. So that is not what you connect is not important. The theme is important. If the input signal, so we are assuming that the equation of the system is theta OT is equal to 10 into V in T, is something which we started to work with, and I questioned you whether this is correct or not. So obviously now this can't be correct because I have added one restriction that this can't change at a rate more than some fixed rate. So if my input is changing at such a rate where 10 into this exceeds, if my input is changing at a rate such that 10 times into that rate is more than the maximum rate at which output can deflect, obviously the output will not be able to follow the input as expected. Is it clear? I explain in Marathi. व्होल्टमीटरचा जो पॉइंटर आहे, अँग्युलर पोझिशन जी आहे, ती किती रेट न बदलू शकते याला लिमिट आहे. एका ठराविक रेटच्या पलीकडे पेक्षा एका ठराविक रेटमध्ये जास्त वेळेने बदलू शकत नाही, त्याला आपण मॅक्सिमम रेट किंवा स्ल्यू रेट म्हणू. मॅक्सिमम रेट ऑफ चेंज ऑफ अँग्युलर पोझिशन with respect to time, and that is there for every voltmeter. For a good voltmeter it जास्त असेल, for a poor voltmeter ते कमी असेल. But since that limitation is there, if your input voltage is changing at a rate such that 10 times that, or input is changing at such a rate for which expected rate is more than the maximum rate at which the voltmeter can deflect, obviously the voltmeter cannot follow this equation. So this equation is not a correct equation, because when it is a correct equation, at all times it must be valid. A correct equation, you can't say that it is valid today and not valid tomorrow, or valid in this case and not valid in the other case. So obviously theta OT is equal to 10 into V in T is not a correct equation. So there is a need to correct this equation, and so I hope you got it. So input is a voltage signal, output is a position signal. Normally speaking, we say that yes, I have mapped it such that I have adjusted the resistance of the voltmeter such that for 4.5 volts I should get 45 degrees as deflection. For 4.5 volts I should get 45 degrees as angle of deflection. So angular position should be 10 times the voltage signal, but because of the situation which I described, means even though I have, listen very carefully, even though I have adjusted my series resistance of the voltmeter such that for 4.5 volt input voltage it should give me 45 degrees deflection, and based on that I have defined the equation as VOT is equal to 10, sorry not VOT, theta OT, that is the output angle, is equal to 10 times input voltage. This equation is not all time true equation, and therefore I need to change, I need to think the way in which this equation gets modified, and this is the crux of the subject signal system that we will continue in the next session. Thank you.